Section 2.2 is on the graphs of functions, and there's not a lot we're going to take out of this outside of we're going to practice graphing functions, but we're going to do it under the guise of piecewise functions. Piecewise functions are hard because you're not just graphing an equation, but you're only graphing it for certain x values. Remember, these piecewise functions are ones that have a restriction on the domain. There's a restriction on what numbers you can use for x. So, for this particular piecewise function, f of x is 2x plus 3 if x is less than negative 1. So one of the ways that I've taught this, I've done it many, many ways, but I want you to find where x is negative 1. There's where x is negative 1. Which side of that line is where the graph is going to be? To the left or to the right? Which side is less than? Less than is to the left. This is the less than direction. You know, the little inequality is pointing in the direction you're going to go. So, I like to make a table of values. And I'm going to start with negative 1. And then I'm going to put a couple numbers that are less than that. So I'm going to start here, and I'm going to start here with an open circle. Remember when we did number lines back in Algebra 1, and we learned about open and closed circles on a number line? If you were to graph this on a number line, you would put an open circle on negative 1, and the arrow would go pointing to the left. That's really what's going to happen here. It's just that the graph of 2x plus 3 is diagonal. So when I plug in negative 1 for x, 2 times negative 1 plus 3 is going to give me 1. 2 times negative 2 plus 3 is going to be negative 1. 2 times negative 3 plus 3, let's see, negative 6 plus 3 is going to give me negative 3. Negative 4 times 2 is negative 8. Negative 8 plus 3 is negative 5, and so on. So the first order pair at negative 1, 1 is going to have an open circle. And all the rest of them are little dots. So negative 2, negative 1, negative 3, negative 3, negative 4, negative 5. And that's really all I need to graph, because the rest of the graph is going to go like that. So this is just the graph of 2x plus 3, where the x values are less than negative 1. The other graph, 3 minus x, is going to exist where x is greater than or equal to negative 1. Greater than or equal to meant a closed circle. So we're going to start with negative 1, and it's going to have a closed circle. And then the numbers that are greater than that are 0, 1, 2, 3, dot, dot, dot. So when I plug in negative 1, 3 minus negative 1 is 4. Remember, those two negatives make a positive. 3 minus 0 is 3, 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 3 is 0, and that's really all I need. So my first dot is at negative 1, 4, and it's a closed circle. And then I'm going to graph 0, 3, 1, 2, 2, 1, 3, 0, and the rest of the graph will go like this. And there's my piecewise function. But those were linear equations. I'm going to stick in here a quadratic and a constant. All right, let's look at this piecewise function. So the first equation is really the graph of y equals 4 when x is less than 2. The graph of y equals 4 is a constant function. It's a horizontal line through 4. So remember, when you're making your table and you're plugging in numbers, such as 2, 1, 0, negative 1, dot, 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 the outputs for all of these will be 4. So you're graphing negative 2, 4, sorry, 2, 4, oh no, I screwed that up. This should say negative 2. I know that should say negative 2. So I'm going to fix that. So I got to fix that. Negative 2, negative 1, 0, and that's, let's see, sorry. The reason I left the mistake, a lot of times I can erase the mistakes, I can stop the video and I can trim it off, but I'm going to leave that mistake here. And the reason I'm going to leave that mistake and own up to it is because one of the hardest things to do for students, particularly if they struggle in math, is to go, wait a second, I made a mistake. A lot of times students think they need to do things perfectly. I don't do things perfectly. I screw up all the time. Matter of fact, I need students to tell me when I'm screwing up. So I'm leaving this here to remind you that it is okay to make a mistake. All right, so now I go back. The domain is x is less than -2. So in my table, I'm going to start at -2. And then I'm going to write numbers that are less than -2. And there are some numbers that are less than -2. I'm going to start with an open circle because it's the less than symbol, not less than or equal to. But because there's nowhere to plug numbers into the equation, all the outputs are the same. So -2, 4 is here, and then -3, 4, -4, 4, -5, 4, and so on in that direction. All right, the next one. I love these compound inequalities. And the reason I love the compound inequalities is it makes my table much quicker. I'm going to go from -2 to +2, and that's it. And it's going to start at a closed circle, and it's going to end at a closed circle, because both of those inequality symbols have lines underneath. So -2 squared is 4. Remember, when you square a negative, it's a positive. -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So I'm going to graph just those 5 dots. So -2, 4, wait a second, -2, 4 is in the same place as that. What happens when you have an open circle and a closed circle on top of each other? The closed circle takes over. -1, 1, 0, 0, 1, 1, and 2, 4. And that is a parabola. Remember, anything with an x squared is a quadratic, and it's a U-shaped graph. All right, the last one is, again, linear. It's really important to know what the shape of your graph is going to be before you graph it. I'm going to start with 2. It's going to be an open circle. And then I'm going to put up a couple of numbers that are greater than 2. Sorry, those are poor attempts at an ellipse. ... So when I plug in 2, when you plug in 2 here, it becomes -2, doesn't it? So it's going to be -2 plus 6 is 4. -3 plus 6 is 3. -4 plus 6 is 2. -5 plus 6 is 1. And then everything goes off in this direction. So 2, 4, again, it's an open circle here, except there's already a closed circle. When an open circle and a closed circle land in the same location, the closed circle takes over. And then we've got 3, 3, 4, 2, 5, 1, and so on in that direction. And there's our piecewise function. In order to do piecewise functions, we just have to do a review of graphing. I like to do a review of graphing by hand because it's great to be able to plug something in the calculator to see what it's going to look like. But when we talk about what is actually happening in a function in our later sections, it's good to be able to graph it by hand because it gives you a better sense of what is happening. The other objective from this section, I can determine if a graph represents a function or not. When you're looking at a graph, the easiest way to tell if it's a function or not is to do that vertical line test. There's actually something called the horizontal line test. We're going to use that in another section in this unit. So, vertical line test. It doesn't matter where I put the vertical line. As long as I never hit the red curve in more than one place, it's a function. So A is a function. B, if I put my vertical line here, I want you to notice that I hit the curve here and here. The reason it's not a function is because a function is defined to have one input having one output. You can't have two inputs going to the same output. So this is not a function. Maybe instead of F and N, I'll use yes and no. Yes, no. C, if I put it there, I only hit one place. If I put it there, I only hit one place. If I put it in the middle, it doesn't hit any place, but that's okay because I never want to hit more than one place. So yes, it is a function. D, not a function. Be careful with the next one. I put it here, that's a bad vertical line. If I put it there, you'll notice that I hit the curve in several locations, not a function. The next one may be choppy, but it's only hitting once. It's only hitting once. It is a function. The next one only hits once, only hits once. It is a function. And D, if I put my vertical line here, I'm hitting the curve in several places, not a function. We're also going to learn as we continue on with this semester how to tell by looking at an equation if something's a function or not. But that's going to require us to do another unit that we haven't got to yet. So our two objectives from this particular section were I can graph a piecewise function and I can determine if a graph represents a function or not.